Hello, welcome back. Today, we will be learning about the singleton pattern. The singleton pattern is a design principle that ensures a class has only one instance while providing a global point of access to that instance. Now, let's delve into implementing the singleton pattern. It all starts with a static reference to the class you want to singletonize. This reference should be public, enabling access from external classes, and it must be static for direct access without the need for an object reference. And then we have the type and the name. Now, let's implement the singleton pattern in our singleton class. As discussed earlier, we begin by adding a public static field. Even better, we can use a property with a private set. This ensures that the instance can be accessed but not modified from outside the class. There's a video on the channel covering properties if you want to dive deeper into this topic. With the property in place, our next step is to assign a value to it. We accomplish this by heading into the awake method of our class and setting the instance to this, which represents the instance of the current mono behavior. Now that you've set up your singleton, let's learn how to use it. So to access the singleton instance, we will use the same syntax that we use to access any static member. That is the class name followed by a dot, and then followed name of the member. And then you can call methods, modify properties, or retrieve data as needed. Let us try calling our example method that we have from another class. In order to do that, let's access the singleton and then call the method inside it. And to make our singleton object persistent throughout scene loads, we will also call the DontDestroyOnLoad method in the awake method. But now there is a big problem, as now there is a chance your object won't just have one instance. Let us see how. Imagine you have two scenes in your game. Let's call them Scene A and Scene B. In Scene A, you create an instance of the singleton, and then you transition to Scene B. And if a new singleton instance is created in Scene B, the old one from Scene A will still be lingering around. So let us now learn how we can avoid this. Let us take our singleton class and remove everything from the awake method. Instead, if there isn't an existing instance, we designate this instance as the singleton by assigning its value to this, calling the DontDestroyOnLoad method, and then returning so the method does not execute any further. Now, if there is an existing instance, we check if it's not the same object and destroy the redundant instance by passing in GameObject, which is simply the object the script is assigned to. Now, let's see how this works when transitioning between Scene A and Scene B. The singleton is first initialized in Scene A. The awake method checks if there is no existing instance, which is true on the first initialization. It sets the current object as the singleton and ensures it persists across scenes with DontDestroyOnLoad. As a result, we have a singleton instance for Scene A. And then we transition to Scene B. In Scene B, the awake method is called again, but now on the new object in Scene B. This time, there is already an existing singleton instance from Scene A. The method checks if the existing instance is not the current object from Scene B. As it is true, it destroys the redundant instance in Scene B, ensuring that the singleton from Scene A persists. As a result, we maintain a single persistent singleton instance across multiple scenes. Let us now look at some key uses of the singleton pattern in Unity. Game Manager. To centralize crucial game functionality, such as managing game state, scoring, and progression. UI Manager. A singleton for managing persistent UI elements like health bars, ensuring consistent display and management across various scenes. Player Data. For effectively managing player-related information, such as scores, inventory, and achievements. Audio Control. A centralized audio manager to maintain control over sound effects and music throughout the entire game. Persistent settings. To easily store and manage runtime global settings, ensuring a consistent user experience across scenes. Input handling. To simplify user input management by utilizing a singleton input manager. This centralizes input handling for easy maintenance and customization. These are just a few examples, and the singleton pattern's flexibility makes it applicable in various scenarios. And that brings us to the end of this video. Thank you for watching. Hope this video helped you understand the singleton pattern and how to use it in Unity. If you found this video helpful, consider dropping a like and subscribing to the channel. With that said, bye, and I'll see you in the next one.